In our previous sessions, we talked about the special binding days. We said the special binding days is an implicit reference to an object. Now, in this tutorial, we're going to be talking about JavaScript prototypes, and then we're also going to be talking about how the special binding days applies to this mechanism, to this concept. Okay, so uh, but to begin with, what is a prototype? So, prototype in JavaScript is a built-in property of every object that serves as a template for inheritance. Now, this prototype allows objects to share methods and properties. So, the takeaway is prototype is at the core of JavaScript prototypal inheritance model. Now, in JavaScript, when we try to access a property or a method on an object. Now, if this property or object does not exist directly on that object, what I'm saying is, if we try to access a property or a method on an object in JavaScript, JavaScript checks whether such property or method exists directly on that object. If in the event that it couldn't find the property or method on that object, what JavaScript does is it looks to the object prototype. Remember, we started this with prototype. So JavaScript looks to the object prototype. If it turns out it still couldn't find the property or method that we're trying to access on that object, it goes a step further and then looks into the prototype's prototype. And it goes on like that into what is known as prototype chain until it gets to the roots or the top of this chain known as object.prototype, which is the source of our inheritance. So if you think of prototypal inheritance as some kind of tree-like structure that has several branches, then you could think of object.prototype as the roots of that tree, if that makes sense. Okay, so there is a way we can check the prototype of an object in JavaScript. So let's go to our Visual Studio Code and let's write some code. Okay, so here we are. I said there is a way we can check for the prototype of an object in JavaScript. So let's play with some code. If I do const empty, and then I do empty object. Now watch this. If I do console.log empty .toString, let's see what we get. Let's go to our browser and then let's open our console. See, we got something. F to string, native code. Let me zoom this in. Let's see what we're doing. Okay. Now, let's go back to our Visual Studio Code. See, I'm calling a property to string on an empty object. In fact, I could go a step further and do console.log empty .toString, the method. And then let's go back to our browser. Say we get object. We're still getting something. Even though we're calling this property and this method on an empty object. Now remember what we said about prototypal inheritance. Say when we're trying to access a property or a method directly on an object, JavaScript checks whether such property or method exists directly on that object. If it couldn't find it, then it goes on to the object prototype to find it. Now, you see that this is an empty object. It doesn't have property to string, nor does it have method to string. So because it doesn't have it, JavaScript goes into the prototype of this object. And then sure enough, it found it. It found to string property, it found to string method. That's why we're getting something here in the browser. Now, there is a way to check what prototype this empty object belongs to. So the way we do that is to use this special method known as object dot get prototype of. So we pass our object here. So we can do empty, for instance. So this will tell us what prototype this empty object has at this point in our code. So if I save, then go back to the browser, you see what we get. So let me expand this. If I expand this, you see, these are all the properties and methods of our object.prototype, which we said is at the root of our prototypal chain or prototypal tree if you like. Okay. Now if I go back here and let's say console.object.getPrototype of empty, if I say equals to object.prototype, this should return a boolean, and then it should tell us whether this will tell us if this is true, then it means that the prototype of this empty object is object.prototype. So let's save and then let's go to our browser and then we get true. Now, ultimately, all objects in JavaScript inherit from the object.prototype. This object.prototype. Ultimately, all objects inherit from this object.prototype. This object.prototype is the object or is the prototype that is sitting at the base. It's at the very base of a prototypal inheritance tree. But then some objects they do not inherit directly from object.prototype. They implement their own prototype, which serves as some kind of blueprint prototype, which can then be used as linkage to our source inheritance, that is the object.prototype. So we have such built-in method, such built-in types like array, like function, like string, and I can show you that. So if I do console.log, remember we're using object.getPrototype of to check what prototype our object has. So if you do this and then say I pass an empty function here, so I'm trying to check the prototype that this empty function has. So I can do is it equals to function? Is equals to function. What am I doing? Function the prototype. If this is true, then it means that the prototype of this our function is function.prototype. So if I save that, what do we get? We get true. So which means the prototype of our function is function.prototype. Now this will be the blueprint prototype that will later be used as a linkage to our root object.prototype. Okay, so we can do for array as well. So the console.log object dot get prototype of, and then I'm going to pass an empty array here. Then if I say is it equals to array dot prototype, let me do for string as well, console.log object dot get prototype of, and then I pass some string here. Then is it equals to string dot prototype. If this condition, if this returns true, then it means that these prototypes are the prototype of these types. So let's go to our browser. So we get true, true, true in each of our cases. Okay. Now, remember we said object.prototype is the roots of our prototypal tree. So what if we were to do console.log object.get prototype of, and then we pass objects. We pass object.prototype here. That is the root source. So let's see what we get here. We get null, obviously. This is the root of our prototype. So this is the source of our prototypal inheritance. Beyond this, it's null. It's the source. You get the idea. So that's why it's returning null. Okay. Now, there is a way in JavaScript that we can create a new object without invoking a constructor function with the new keyword. So the way we do that is to use this special method known as object.create. So the object.create is a static method in JavaScript that creates a new object using an existing object as the newly created object prototype. So this is better demonstrated and explained. So I'm going to take this off, and then let's have const quotes. So let's have an object quotes, and then I can create a method here. I can say quotes. So what do I want to do? Then I can do console.log. I'm going to do a template string, which quotes the metaphors of the mind, this dot type it perceives, like that. So this is our quote. Now we can create a new object using the object.create. So I can do const result equals object.create. So when I use this object.create, I can create a new object from an existing object. So I can the existing object I want to use is this quote object. So I can just pass quotes inside of this. So at this point, these new objects and this object, they will now implement the same prototype. So that prototype will be used as a blueprint that will be used as a linkage to our root object.prototype, if that makes sense. Now, when I do this, what I'm trying to implement is prototypal inheritance. So when I create an object, a new object, this object using the object.create, and I'm passing an existing object here, these new objects will now share the same property and method with the old objects, if that makes sense. So because of this now, I can access this method, even this property, from this new object results, such that I can do results dot type. So now I want to set the value of this property type. Now this refers to this object quotes. Okay, so now I can do reality like that, such that if I do results dot say quotes, color like that. Now let's go to our console. Let's see what we get. Now we get the metaphors of the mind are the reality it perceives. See, this new object is now sharing the same property and method as this old object. And we're able to create these new objects using the object that creates. We didn't use the new keyword. We didn't invoke any constructor function. We just use object that creates, and we pass in an existing object. And then these objects now share the same prototype as this new object. Hopefully that makes sense. So result type is reality. Result say quotes like that. In fact, I could do console.log results.type. So if I do that, what happens? I get reality. See? So this object and this object, they're not sharing the same property and method. So that's the core idea of prototypal inheritance. Now, we can take this a step further by using constructor function. And I'm going to show you that. So to implement that, I'm going to get rid of this. And then we're going to create a constructor. So what do? We can do function. And then I'm going to do person. Then I'm going to pass a parameter inside this constructor. Now, look at this. We're starting with an uppercase letter. So this is the convention for constructor in JavaScript. So we can now do this the name equals to name. So we're saying the object this that this constructor belongs to has a property name, and then we are setting that property, the value of that property, to the value of this name that the constructor takes as its inputs. That's what is going on here. Now, we can bind a method to this constructor function by calling the prototype. Remember, the other time we said some built-in types implement their own prototype. And one of those is function.prototype. So we can use function.prototype here to bind a method to our object this. Remember, we also said the function.prototype or array.prototype, that is those prototypes that those built-in types implement, they're going to be used as a blueprint object or blueprint prototype that are going to be used as a linkage to our root prototype, which is object.prototype. Hopefully that makes sense. So we can bind a method to this constructor function by calling that prototype that is that belongs to our function, that is function.prototype. So what I'm trying to say is we can do this person.prototype dot say hello, for instance. Say hello. And then we can define a function here. And then let's say we say return. Let me use template syntax. Let's see. Hello everyone. Hello everyone. I am okay. My name is. Then I can do this dot name like that. So what we're doing here is we are binding a method, say hello, to this constructor function using the prototype, using a function of prototype, that is the constructor, the prototype, passing the prototype here. This prototype is not to be confused with our root object of prototype. No, it's an instance of that prototype. So that's that. Then we can take this a step further. Let's say we create a property. Then we can say person dot prototype dot maybe species, and then it is human, like that. Okay. Now we're trying to implement prototypal inheritance using constructor function. So which means we need another constructor with this mechanism that we're implementing. So let's create another constructor. So we can do function. Let's say function developer now. And then here, let's pass our parameters. Say name. Then let's do language, like that. And then here, we can call this constructor. So when we do person dot call, like that. And then we pass the object this, special binding this. We said it's an implicit reference to the objects that this function is the constructor of. So then we can do name, like that. So we're explicitly calling this constructor function here. So what is happening here is this developer function is extending this person constructor function. So we can then do, because we have to pass the value of our language property in our object, and then we have to, so what I'm trying to say is I can do this dot language equals language. So we're setting the property of language to the value of this input language, like that. So okay, so we're not done. What we now need to do is we need to create a new object without necessarily invoking this constructor function. So without using the new keyword to invoke any of this constructor function yet, we can create a new object. So remember the other time we said when we can create a new object using object.creates, and then we pass an existing object inside that object.creates, is we pass an existing object as an argument in our object.create method. So then we can do developer.prototype equals object.creates, and then we pass person.prototype here, like that. Remember the other time when we discussed object.prototype or object.create, we said the object we're passing here, we have the same prototype as the prototype here. Now this prototype belongs to this function developer, this developer constructor function. It's like function.prototype. So it's the blueprint prototype or the blueprint objects that will now be used as a linkage to our root object object.prototype when we use a new keyword to call our constructor function or to create a new instance of our objects. So this constructor has the same prototype as this one. So whatever object we pass in here, we have the same prototype as this one when we use the object that creates. Okay, so let's continue. Now we have to set the constructor of our new objects. And the way we do that is to call the constructor function, then developer.prototype.constructor, and then we're going to say this to developer. So what we're saying here is we want the constructor of our new object to be this constructor, developer, like that. So we can do more. Maybe we say we can bind another method, let's say code, to this developer function using the prototype. Then we say function, then I don't know, what should I do here? Say return, hi everyone, I code this language, like that. So when we do object.creates, we're creating a new object. So now we're implementing prototypal inheritance so that the two objects, they now share the same method and property. So now we can create a new instance of our constructor function using the new keyword. So we can do const dev, and then we do new developer, like that. So developer takes two parameters, name, language. Okay, so the first one can pass Hola, and then the second one can pass JavaScript, like that. So we can call either of these property or methods on this instance dev. So I can do console.log dev.say hello, like that. And if I save, I go back to the console, I get hello everyone, my name is Hola. So the two methods, as well as the two objects, are now, so from this instance of this developer constructor, from this we can now access the methods and properties of these two constructor functions. Remember, we have linked them together using object.create. Now they share the same blueprint prototype that we can now use as the linkage to our root object.prototype. So we've used dev to access say hello. Remember, say hello originally was created under this person, was created with this person constructor, but now we are accessing it from this instance that we created with the developer constructor using the new keyword. So we can also do more. We can do console.log. What other method do we have there? Let me go up. We have species. Good. Then we can do dev.species. So what do we have there? Let's go. Now we have human. Remember, here, up here, we said personal prototype of species equals human. So now we are sharing the same property and method, prototypal inheritance, guys. Okay. What other? Now look at the code. This code method. Then I can say console.log dev.code like that. So what does code say? Code says, "Hi everyone, I code this the Java, this is the language." So language has been, the value here has been set to JavaScript. So if I save, then we should get, "Hi everyone, I code JavaScript." So what else do we have here? I think we're done with, okay. So guys, that is JavaScript prototype. There's a cleaner approach to this with classes. Although under the hood, classes still implement prototype. But then JavaScript classes offer us some kind of syntactic sugar that sort of abstract us away from all of this meta programming that we've done so far. So in the next video, we're going to be talking about classes, and then we're going to be re-implementing these using classes. Okay guys, thanks for watching. I'll see you the next time.